Hello guys, welcome to my YouTube channel. In this video, you will see something called as vectorization. This is specifically a method used to avoid for loops in order to calculate our hypothesis or gradients. In general, how we can avoid the for loops, okay? So we have our hypothesis. If you just take an example of simple linear regression, our hypothesis is theta 0 x0 plus theta 1 x1, correct? So in order to calculate this, usually we have to run through two for loops, right? So the first for loop will iterate over all the training examples. So starting from 0 to m, right? Here there will be one variable, we will be initializing it to 0. Then what we will do, we will iterate over all the features starting from theta 0 or x0 till nth feature, right? So what we do, sum is equal to sum plus we say theta of I, theta of j, okay, into xi, ith training example, jth feature, okay. So this is how we can calculate the hypothesis. If you just substitute I and j values here, you will get to know we will be arriving at the hypothesis, okay. So j will be 0, theta 0 into x 0, 0, right. So it can be written as theta 0 x 0. Then in the next iteration we will be adding with theta 1 because j will be incremented to 1, theta 1 into x1. So this is how we arrive at the hypothesis using for loops. Using this for loop will result in most time consumption process, okay. So wherever it is possible for us to avoid the for loop, we need to avoid it, okay, because machine learning or artificial intelligence, we will have thousand or hundred thousands of records, okay. In order to iterate over millions of records using for loop, it will take a lot of time. So how we can avoid that? So there is something called as vectorization technique. So what we can do is, in order to understand vectorization, we need to understand matrix multiplication process, okay. So let's say we have one matrix A and another matrix B. So how do we represent the shape of the matrix? Number of rows and number of columns, correct? Number of columns. So usually we represent number of rows as m and number of columns as n, okay. So in order for us to have the two matrices multiplied, we need to make sure columns in first matrix, number of columns in first matrix must be equal to number of rows in second matrix, correct? So this is the general rule for matrix multiplication, okay. So this is the first important rule. So how the matrix multiplication works? Let's say we have some numbers here, 1, 2, 3. This is A and this its size is 1 row and 3 columns, right? And then let's say we have another matrix B which will be 2, 3, 4, okay. And the shape of this matrix is 3 rows, 1 column, correct? So can these two matrices be multiplied? Yes, we can multiply this. Why? Because number of columns in first matrix is equal to the number of rows in second matrix, okay. So the output of the matrix multiplication will be of shape 1 cross 1. So it will have just 1 row and 1 column. So we will end up with 1 number. So what is the product of this? So how we can do that? So in order to multiply the matrix, all we have to do is 1 into 2 plus 2 into 3, right? 2 into 3 plus 3 into 4, right? 3 into 4. So the end result will be 2 plus 6 plus 12. So it will be 20. So this is how we multiply the matrix. In order to develop our hypothesis, okay, this is our simple linear regression hypothesis. Let's say we have only two features, x1 and x2, and as usual we will always add our additional feature x0, which will always be equal to 1 in our data set, okay. So our hypothesis can be written as h theta of x is equal to theta 0 x0, theta 1 x1, theta 2 x2. So this is our hypothesis for simple linear regression. Now, if we can represent theta as a vector, okay, it is also called as column vector because it has one column. Okay, this is called as column vector. We arrange thetas in a column. So we have two features. Features or n is equal to 2. So number of params will be n plus 1, right? N plus 1. So we'll have theta 0, theta 1 and theta 2 as the learnable parameters. So if we can arrange this as a column vector, and also let's say we are dealing with only one training example as of now, we can arrange the one training example as a column vector again. Okay, column vector. So if we can arrange it like this, x0 is the zeroth feature, which is always 1, x1 is the first feature, x2 is the second feature. Okay, now in order to have this matrix multiplication, just look at the shape, guys. This theta shape is 3 into 1, this x shape is also 3 into 1, right? Since the numbers are not matching, the number of columns in the first matrix is not matching number of rows in the second matrix, we cannot directly multiply it. Okay, so what we can do? We can take the transpose of this particular theta. So what do we mean by transpose? When we take the transpose, rows becomes columns, columns become rows. Okay, so in this way, the shape of this theta transpose will be 1 cross 3. So now after transposing, this particular theta matrix will have 1 row and 3 columns. So you can see theta transposed here, 1 row and 3 columns. Okay, and then x, it will be untouched. The shape will remain 3 cross 1. Okay, so now if you check the shape or the number of columns in the first matrix is equal to the number of rows in the second matrix. So if this condition satisfies, we can have the matrix multiplication. Okay, so now if I say theta transpose x, this is a, treat it as a matrix multiplication. Okay, matrix multiplication. So if we multiply it, what is the output? So the output will be of shape 1 cross 1 because we have 3 columns in first matrix, 3 rows in second matrix, but number of rows in first matrix is 1 and number of columns in second matrix is 1. So the output will be the remaining numbers here. Okay, so 1 cross 1 will be the output. So how we can do that output? How we can multiply? So it is simple. Theta 0 into x0, right, plus theta 1 into x1, right, and then theta 2 into x2. So this is nothing but our hypothesis, correct guys? So if you check here, you see this is our hypothesis, right? So this is the case when we have just one training example. So what if we have m training examples? So in that case, we can represent our x matrix like this. We can stack all the training example vertically. Okay, let's say we have m training examples. In our notations video, if you guys have seen it, the number of training example denoted as m, right? So if we have m training examples, we can stack each of the training examples vertically so that the shape of the matrix will be n plus 1 cross m. Why n plus 1? Each training example will have n plus 1 features. Okay, if we have n features, we are adding x0 as an additional feature so that it will become n plus 1. So the number of rows will be n plus 1 and the number of columns will be m. So each column represents one training example. Okay, so please understand this. Each column for us in this particular x matrix represents us one training example. And then coming to theta, theta will have n plus 1 cross 1 shape. Why? Because we have n features, the learnable parameters will be n plus 1 and we are arranging it in a vertical stack. So it will be a column vector. So this will be the shape. Now if you check the shape of theta, it is n plus 1. Sorry, I'll write it again. It is n plus 1 cross 1, n plus 1 rows and 1 column. Shape of x will be n plus 1 cross, instead of 1 it will be m. Okay, why m? Because we have m training example. Now, if you take the transpose of theta, the shape of the theta will be 1 cross n plus 1. If you guys remember, if you take the transpose, rows will become columns, columns will become rows, correct? So, if you take the theta transpose, it will look like a row vector. Instead of column vector, we will be having row vector. Okay, the transpose of theta, if it looks like this, it's also called as a row vector. Okay, so now the shape of theta will be 1 cross n plus 1, and the shape of x we have is n plus 1 cross m. Since the number of columns in the first matrix is matching the number of columns in the second matrix, we can have the matrix multiplication, and the resulting output will be 1 cross m. So the resulting output will be 1 cross m. This will be the output shape, 1 row and m columns. So if you just think of this peacefully, you will get to know we have m training examples. So we will be getting m columns. Each column will represent the hypothesis for individual training example. So how do we work out the matrix multiplication in this case? So all we have to do is take this theta row vector, multiply with individual examples one by one. That's it. So each column represents one example, right? So first take this set of theta, multiply with this first example. Take this theta again, these thetas again, multiply with the second training example. Like this, you go on multiplying with till you reach the mth training example. Okay, so let's see how it goes. We can say theta 0 into x0, right? First training example is denoted over the x, we can denote 1, 2, 3 to represent mth training example. Okay, so this represents first training example, 0th feature, second training example, 0th feature, second training example, first feature. Likewise, we have m training example and n features. Okay, so we can access them individually. So all we have to do is theta 0 into x1 of 0 plus theta 1 into x1 of 1 plus theta 2 into x1 of 2, like this, theta n into x1 of n. So till nth feature, we will multiply with all the thetas for one training example. So once we are done dealing with the first training example, we will move on to the second set of training example. That is second training example. Okay. Now if you take theta 0, we are already done with this, right? So we don't have to worry about this. Now all we have to worry about is the second vector, second column vector, which deals with second training example. Okay. So it is like this, theta 0 into x2 of 0, theta 1 into x2 of 1, okay, theta 2 into x2 of 2. Like this, we will multiply till the end, theta n into x2 of n. So like this, we can multiply this theta row vector with all our individual column vectors or training examples till we get the output multiplied between the multiplication between the theta row vector and individual training columns. Okay, training examples. So the resulting output will be 1 cross m. So here each column represents hypothesis on single training example. So what do we mean by this? So let's say for first training example, hypothesis of x1, okay, we can call it as hypothesis for first training example, theta 0 into x1 0, right, plus theta 1 into x1 1 plus theta 2 into x1 2. Like this, we will go till the n, theta n x1 of n. So this is hypothesis for first training example. If we take the hypothesis for second training example, it will be theta 0 x2 of 0 plus theta 1 x2 of 1. Like this, we can go on till theta n x2 of n. Okay. So similarly, for last training example, that is hypothesis for xm, mth training example, we can say theta 0 x m0 plus theta 1 x m1. Like this, we can go till theta m, theta n x m n. Okay. So each column here represents hypothesis for that respective training example. So this is how we can avoid the for loops, and this also helps in speeding up the computation while we are dealing with the hypothesis calculation. Okay. So generally, wherever it is possible, it is advised to avoid the for loops. Any looping construct in that case, if we can do the computation with the help of vectorization like this, we need to make use of that to avoid the wasting time on computation. Okay. So that's all for this video, guys. Hope you understood it. If you guys have any questions, please reach out to me. I will try to answer via the comment section. Okay. So till we see in the next video, happy learning. Bye bye.